Good morning and thank you. I'm presenting this talk about one of the operational groups of our viticulture research team here at Università Cattolica del Sacro Cuore. The project funding the activity is a rural development plan project of the Emilia-Romagna region called IN+VITE. And well, actually it is a quite wide project focusing on one specific activity, which is the testing of hydrogel efficacy in vineyard, specifically for vineyard under establishment, because one of our main problems in hilly non-irrigated viticulture is the fact that at vineyard establishment, we pass through an unproductive period that can last several years according to water availability, soil traits, and many different other aspects. Specifically, one of the main reasons is the fact that plants have root system occupying only the upper soil layers that are the most prone to desiccation when temperatures rise. And in absence of irrigation, of course, this leads to a reduced vine development, vegetative growth, to the increase of vine mortality if conditions are quite severe. And for this reason, of course, a grower needs several years to get to the productive stage. Our project focus on an instrument, a tool, which is not actually new for agriculture, but it is quite new because new formulations have been released recently, and they're called hydrogels. Hydrogels are network of cross-linked chains very rich in hydrophilic groups. What does this mean? This means that once water is added to hydrogel, this absorb water thanks to the hydrophilics group, and they make this absorption in a very relevant amount as compared to their relative weight. They can absorb from 10 to 304 times the water in weight as compared to their dry state, so a significant and high absorbance of water. We can see three different hydrogels here. From left, polyacrylate hydrogels, and on the right, an organic-based hydrogel. Than organic agriculture. Our goal were understanding how these hydrogel work, if they release water at compatible threshold with grapevine uptake, because we don't know really anything about the real mechanism of action and what they do once they are implemented into the soil. And then we tested under control condition and under in operative environment, so in vineyard establishment. As we can see from the table, the water absorption is significantly high and significantly different between the hydrogels, and so every hydrogel has a different absorbing water capacity. Reabsorbed water doesn't really change after the dehydration process, and water loss is mainly driven by the temperature and the water accumulated, the degree of absorbing water. Most importantly, below we can see that the water absorbed is made available at a threshold of water potential which are from 0, and we can see the threshold of minus 1.5 megapascal, meaning that most of the water, almost 95-90%, depends by the specific polymer. Every polymer is a little bit different about this, makes water available at water potential that are compatible with water uptake. And this is one first assumption which is very important for us to go ahead testing them. Then we added these hydrogels to a soil, to actually a sandy, loamy clay soil. We can see called here substrate, and in an amount so that they can a similar maximum water absorbance of water absorbent of 0.2 milliliter per gram of soil. In fact, there was no difference between the different hydrogels when incorporated to the soil, but all of them were significantly absorbing more water than the substrate alone. This is the fill capacity on the left column, and so the hydrogel increased significantly the fill capacity, as we can see. At the second rehydration, after the rehydration cycle didn't change anything really. The wilting point was actually shift and increased, but not so much like the field capacity. So at the end, all the different superabsorbent hydrogel were effective in increasing the maximum plant water availability, the plant available water that we can see on this column, and this was very relevant. They are not all the same. We can see that the higher plant available water increase occurred in superabsorbent hydrogel 1, a polycrylate based hydrogel, while this was slightly lower in SH2. But most importantly, we see in the below graphics the substrate in yellow and the substrate with the polymer added with the colored lines, and we can see how adding the different substrate, even if the field capacity was increased in the same way, led to a different soil hydrology and different constants in the three different treatments. Actually, we can see SH1 moving, shifting on the right, this correlation in a low manner, while SH2 is shifting a lot on the right, this correlation between soil water potential and the soil water concentration, meaning that the same water concentration is made available at different soil water potential. What does this mean? That the superabsorbent hydrogels are capable of shifting a sandy clay loamy soil to a soil that is withholding better the water that is absorbing when water is available. Testing the hydrogel in potting condition, we tested SH1 in these pots on Sangiovese after planting, and we can see more or less how does this work. We imposed a progressive water stress, reducing by 50% evapotranspiration at this point, and we can see how the control during the mid hours of the day started to have this decline every day, and then recovering when the 50% of evapotranspiration was applied in the night, while the SH1 treatment, superabsorbent hydrogel 1 treatment, didn't have this day-night fluctuation at all, even when water was reduced by 50%. When water was reduced, one of total was fully suspended at this arrow, we can see that the soil water potential of the control dropped to very low values, while the soil water potential of the substrate added of superabsorbent hydrogel 1 had a delayed loss, significantly delayed loss, and to lower levels of 0.2, 0.3 megapascal of difference, which is actually a lot when speaking about soil water potential. After it was repristinated, a higher water potential on SH1 like before, because also in absence of water stress, there was this difference. We tested the hydrogels in field. This is SH2 tested in field versus the control. We can see that SH2 improved the length of the 2 shoots. We standardized shoots with 2 shoots per vine, and the sum of the 2 shoots was significantly higher in the SH2 treated vines, but most important, number of dead vines was significantly lower in SH2, 6.2 versus 15.6. Concluding, superabsorbent hydrogel were effective in changing locally the soil hydrology They make a significant fraction of water available at water potential which are actually compatible with grave and root systems uptake. Further studies are of course needed to study different characteristics of soil and efficacy. We tested them and proposed them for new plantation because the cost is still quite high, but should be reduced because scale mass distribution should make hydrogel available at lower price. But at the moment, from an economical point of view, it is possible to use hydrogel. It's compatible, economically viable to apply hydrogel to satisfy the water exigencies of young plants. Adult vineyard, a mature vineyard, leads to a significant hydrogel application in soil and to costs that are quite high at this point. Then mechanized application can help surely in the reduction of cost. As a last, I want to mention Riccardo Colivasone, Clara Ripa, and Pier Giorgio Bonicelli, which are the three students that helped and was the core of the project. Thank you.